platform sales leader at Redhat, and today's session will be driven by him. He's specialist in OpenShift and automation platform of Red Hat Ansible. He's an ex-HP, ex-VMware, has tons of experience, and especially in the software assessment, automation, virtualization, and the container platform. So I'm very glad to host you, Balbaki, today, and we have a good list of attendees today, those who are keen to know about the containerization. So I welcome all the attendees today. Thank you for joining in. Hope you are all keeping safe in this pandemic times, and just be careful because the cases are on rise. Today's agenda is to discuss about the Red Hat OpenShift, which is the next generation platform for containerization. Containers are the next generation approach to virtualization, and they are very efficient vehicles for the development, application development, and deployment. Okay, so today we are going to start from the basics of what is OpenShift and how it can help your organization to set the stage for your next digital transformation. So I'll hand over the baton to Balbaki. So please, sir, continue.
Yes. Thank you, Namita, for the introduction, and good morning and good afternoon if anyone is joining from outside this region. It's my pleasure to be here today with the Redington team and with the partner ecosystem to tell you more about about the Red Hat OpenShift platform and how it's helping our customers to really speed up application development and move into the hybrid cloud deployment. I'm sure you all are familiar with Red Hat as a company, so I'm not here to tell you what Red Hat is doing in the region, but I'll be more than happy to explain to you what is the Red Hat OpenShift container platform, what's the latest that Red Hat is bringing to this platform and to our customers, and how this platform is evolving rapidly and is becoming more and more the de facto platform for the modern applications and innovation, for bringing differentiation to our customers. So the presentation today is about the next generation platform for big ideas, right? I think it's a strange name for a technical product, bringing ideas with a technical, product. But you might ask why is that, right? Why big ideas? Why people need big ideas? Why the ideas are changing the marketscape and allowing organizations to be more and more competitive and allowing other organizations to survive, in such a changing, landscape that we are living in. So to tell you more about this, we all understand that the world is changing today. We are under a massive change in terms of the market dynamics, in terms of different, impacts, whether it's the COVID, effect, or it's the competitive landscape, or emerging markets, or the whole, industries that are being basically under threat of being replaced by new entries into the market. So we're living in a very challenging world, and organizations today need to innovate and need to differentiate themselves. They need to come up with new ideas, with new capabilities, to really impress their customers and to reach their customers in a better and more effective way. Now, in such a changing world, big ideas are crucial to business innovation. So when we look at organizations in every geography and across every industry, right, they are looking to create more value and to differentiate themselves and to leverage capabilities that gives them this edge. So they are looking at trends such as basically AI and machine learning. They are looking at open source technologies where the whole innovation is happening. They are looking for open culture to come up with innovative ideas and bringing more collaboration with their teams to drive better value out of their existing ecosystem. They are looking for different types of digital tools to help them speed track and to have business intelligence about how they need to speed up their value to their customers and respond to the business needs in a much faster way. So we live in a world where customers expect immediate results, and organizations need to move very fast, and they need to deliver value and differentiations and services and products in a much faster way. To be able to do that in such a challenging world, customers need to leverage capabilities that they have from their data, and they need to deliver applications and services faster to their end customers. Because if we look at how the world is changing around us, software is now embedded into almost everything we have and everything we do, or everything we use on a day-to-day basis. Whether you go and buy a toy to your son, or you go or buy a home appliance, or you need to buy a new car, software is embedded into each and every product you buy today. So the differentiation that these organizations want to bring, or want to basically emphasize on, or they want to leverage, comes from software, comes from their ability to leverage the data that they have, and their ability to deliver these changes and these new products and these new services faster to their end customers. This is a main need. And to be able to do that, organizations are leveraging a lot of the open source innovation, and coming up with trends such as, AI and machine learning, IoT, blockchain, innovative cultures from the open source as well as, developing applications the modern way, the new cloud native way, which is fast, agile way, in order to bring differentiated services to their customers faster. So we live in a world where every business today is a technology business. And within that technology business, software plays a big role, and data, and where, the real value is when we have code being deployed in production, rather than code taking months to be deployed. So the faster that we bring code to production, the better services we can give our customers, the better market share that we can give, the more competitive we can be in the market. So in such a world where software and data and speed and agility, to respond to changing needs is crucial, this is where open source more and more is becoming the IT standard. So customers and partners are looking into open source as the engine of innovation. Because if we look at the trends around us, right, whether we're talking about cloud, they are all fueled and powered by open source tools. Data and analytics, container platforms, management, automation, they are all the latest tools, all the latest trends are fueled from the open source and are coming from the open source. So open source is the innovation engine of the modern enterprise. And we look at all the emerging technologies and all the transformational technologies are all based on open software development. And it's not only now becoming mainstream, but it is becoming the de facto standard of how modern enterprises want to build their new software stacks. And Red Hat, basically, we are proud to be the world-leading enterprise software provider based on open source development model. So all the products you get from Red Hat are developed in the open source. We don't develop products for our own in our own data centers. Rather than we contribute to the upstream and we develop our products in the upstream. So as you can see here on the slide, in the center we have these over 1 million open source projects, and Red Hat contributes to part of these projects that are relevant to our customers, that are relevant to our strategy, and we combine these projects into products into open source product that we contribute to the upstream. For example, we have the Fedora for the Red Hat Linux, we have the OKD for Red Hat OpenShift, we have Gluster and Ceph for the Red Hat storage, right? These are the projects that we contribute to in the open source. But when we want to provide our customers the enterprise, secure, stable product, we give it to them as a Red Hat supported product that is fully certified, fully documented, with the right governance, with the right security controls, and all the bugs are fixed, and the support level is as needed by the enterprise. So this is the model that Red Hat operates in. We are born in the open source. We are the largest and the leading enterprise software provider based on an open source development model. So that gives Red Hat the edge of how we are able really to help our customers develop product services faster and develop the cloud native way and move into the hybrid cloud, because we are born in the open source, and we are pioneering. We have pioneered before the open source model. So we look at all of these changes. We look at what we have discussed earlier. The need for speed, the need for software to develop software, to release software faster. So how does this impact the traditional IT that we have today in the data center? Definitely, the IT stack that we built in the past couple of decades will not be the same IT stack that will take us the next decade. The technology is evolving fast. Business needs to move even faster. The customer expectations are becoming instantaneous. They want instantaneous results. They want immediate feedbacks. They want everything from the business now. And the business needs to be agile to respond to these needs. So definitely there is a big impact on the IT, and the IT needs to evolve in what we call the idea economy. We call it the idea economy because these ideas, the new competitive things that each and every organization needs to bring, they need a platform, right? They need technologies to enable them. They need resources and tools to get these new ideas up and running into production quickly, right? Again, we go back to the concept of code is not efficient, or code is not basically valuable if it's not deployed in production, So we need to make sure that when we have a new idea, we are able to codify that idea, and we are able to move that idea through the automated basically tool chain that we have to bring it into the production in a much faster way. So in such a world, we look at how our customers are developing applications and software, and we see this evolution from a waterfall methodology into agile and lately into DevOps, right? The idea of DevOps is to basically have completely automated way of moving code relevant to a new idea or a new service or whatever the customer wants to deploy, and automate the testing, integration, deployment, and motion of this idea or code between the development, quality assurance, pre-production, and production environments in a fully automated way, and where the development teams and the operations teams are working together, collaborating together on a unified platform, bringing that code into production in minutes, right? So this is where we are today. We need to move and evolve the IT. And when we look at the application architecture as well, right? And traditionally, we had monolithic applications with a single code base where all the features and services of a single applications are codified together, right? And this makes it very static, makes it very hard to really change any component of that application because it's going to affect all the code of that application. So we need to retest and reintegrate the whole code, and we need to, move again manually between the different, environments from development to quality assurance to pre-production and then production. So we are moving into a multi-tier and now lately into microservices where we are able to decompose parts of the application into separate services that we are able to manage separately. We are able to give each and every service its own tools, its own languages, its own frameworks, and different teams can work on different services at any time. And all of these services are now connected to each other through APIs. So we move into what we call the API, economy, and API management is now needed as part of the new microservices architectures of modern applications. So again, we are seeing a modernization in the development process. We are seeing, modernization in how application architectures are being, modernized, and we look at also the deployment of those applications. And we all are seeing, this kind of evolution from physical, platform into virtual, and lately into containers. So again, the idea is basically that containers today are a prerequisite or a big enabler for customers to achieve DevOps and to achieve a microservices architecture. So these go hand in hand, right? Because the ability to package modern applications in containers makes them lightweight, makes them portable, and you are able to package the application with all its constituents inside it. So containers become the de facto standard of modern application packaging. And because of that, with containers, microservices architectures become, much more relevant and easy to do and easy to manage. And also DevOps, the ability to develop applications in a fully automated way and move them to production in a fully automated way becomes a reality. So containers are a necessity to achieve these platforms. And because containers are portable, because containers rely on Linux and Linux is available everywhere, we are able to deploy across multiple hybrid clouds, and we are able to move from the data center to a hosted platform to a fully cloud-enabled and hybrid cloud delivery platform. So these are the trends that our customers are looking to modernize their IT. This is how they look at their the technologies of yesterday that they have worked in the past 1 decade or more on. Okay, the waterfall methodology, the monolithic applications or multi-tier, the physical and virtualization platform and hosting in the data center. And what our customers are demanding today and tomorrow, they want to move into the agile, the DevOps, the microservices, the container platforms, and the hybrid cloud. And this is the architecture of tomorrow. So Red Hat is here to help our customers optimize whatever they have in the data center today, and we are able to bridge them into the world of tomorrow by building a unique single platform that is able to give them all of these capabilities in a unified architecture, in a unified platform, and help them leverage whatever they are using today and connect with that and integrate with that, but give them all the tool sets as well and the platforms to become more agile and move into the hybrid cloud deployment. So this is the whole story behind the Red Hat, OpenShift container platform. It's the platform that will help our customers move from the world or from the IT stack of yesterday to the IT stack that will enable them to build on for tomorrow. Now, few facts, okay, just to level set. Virtualization technology that we have built, starting in the early 2000s or even before, is now a commodity. So virtualization is not an edge, and according to Gartner, if you look into within the rectangle, the red rectangle, right? They retired the Magic Quadrant almost 3 years ago. And why is that? If you look into the notes, they highlight that more innovation is focused on container technologies that support developers and cloud services that use virtualization. So innovation is headed towards container platforms. So container platforms is the future. And for virtualization, it was a cutting edge technology back in the time, right? Almost 20 years ago, but today it's a commodity. So virtualization will not give our customers the edge. And also this is another, another study that shows that most of the customers, almost 45% of large US enterprises, believe that half of their production applications will use containers in the next 3 years. So again, we'll see this shift, the major shift of applications today being hosted on virtualization and moving into being hosted on container platforms, not because container platforms are nicer or it's the new trend. No, but because it brings real advantages to application packaging. So managing the lifecycle of applications becomes easier. Developing and modernizing these applications becomes much easier. And deploying these applications across hybrid clouds becomes a reality. So that's what's driving the modern applications moving into containers. So based on that, I would like to just go back to the basics, right? What are virtual machines and what are containers? So on the left-hand side, we see the traditional virtual machine platform, the virtualization platform that we have lived with in the past 2 decades at least. So where we basically have a physical server, and on top of that physical server, we purchase a hypervisor, right? So we need to pay for that hypervisor. And then we need to start to build virtual machines, the ones that you see in purple color. And in each and every virtual machine, we host the application and the application dependencies. But at the same time, we need to buy a complete operating system for each and every virtual machine, right? So again, we need to buy the physical server, we need to buy the virtual machines, and we need to buy as well the hypervisor. right? And the operating system in each and every virtual machine. So that's a costly deployment model. Not to mention that when you deploy an application in a virtual machine, there's a lot of friction, right, and dependencies that happen between the application and the underlying operating system. Okay, so this is one area of friction that developers, when they want to develop applications and they want to basically test these applications, integrate and move them from development to testing to pre-production, it's a challenge for them because of that dependency and configuration dependencies between the application and the operating system. And there's also another kind of friction, which is between the virtual machine itself and the underlying hypervisor and infrastructure underneath it. So again, there's also a friction between the virtual machine and the hypervisor. So for developers, the old world was okay with the virtualization, but it was not optimal. It didn't allow them to really move at the speed the business wants, and it didn't help them become agile, and microservices architectures were not really efficient in how they were deployed. And the life cycle of applications, was not optimal in terms of how it was managed with traditional virtualization. So this is where we move to the right-hand side of the slide, where container platforms started to come to the market, right? And when we look at, the architecture of or the layers of a typical, container platform, as you can see here, we start with the physical server, and on top of that physical server, all what is needed is a Linux operating system, right? So the Linux is the enabler of container platforms because containers are Linux, right? Containers are a Linux feature. Containers are not a new technology. It's not a new innovation, right? It's just a feature of the Linux operating system that was basically started to be leveraged and used at wide scale by organizations such as Docker in the early days, and then it became standardized and how container image needs to be packaged, and then it was massively deployed and used by developers all around the world. So again, containers are Linux; they depend on Linux, and then on top of that operating system, you start to create containers, and each and every container only requires the application and the application dependencies. And each container shares the libraries of the underlying operating system, so there's no need to have a separate operating system deployed in each and every container. So for organizations in such an architecture, they are saving on the cost of the virtualization technology, and they are saving on the cost of the operating system inside each and every container. So here we come to a more optimized deployment model. Not only this, but also the container platforms, there's now less friction between the application and the underlying operating system. So developing applications, modernizing application, managing the life cycle of applications becomes very fast, very agile. And we are putting also all the dependencies of each and every application within that container. So again, with the container platform, we are able to run multiple containers, each running separate process, isolated from each other. And it is much lighter than a virtual machine, much portable than a virtual machine, because all the container needs to run is an underlying Linux operating system. And then for an organization, they can develop on their laptop and move it into testing, and then move it into pre-production, and then move it into production or into any public cloud easily and quickly, because all what the container platform requires is an underlying Linux operating system. So this is the new word that the modern applications are being modernized at, and this is basically what all the modern application packaging is moving towards. So I hope that I gave you an idea about containerization and virtualization. So with virtualization, the hypervisor virtualizes the physical server, while with containerization, the container platform virtualizes the underlying operating system to be shared across the different containers. And we end up with a much lighter application packaging, much portable application packaging, and a standard way of packaging, deploying, and manage applications, and the ability to deploy these across physical environments, virtual environments, and across hybrid clouds. So again, great advantages to everyone. Now, this kind of architecture of containers has advantages to different team members in the organization. So for developers, it's now it's the standard way of building cloud-native applications. It simplifies the packaging of applications, whether they are the traditional ones and the new ones, and it simplifies testing and the whole DevOps, the development cycle from developing applications to moving them into production becomes very simple, very easy, and fully automated with no dependencies on the underlying operating system or the underlying infrastructure. For IT operations teams, definitely there's also a lot of advantages. So now we have a consistent way of developing applications and a consistent way of managing these applications. And if the application works well in the testing environment, you can guarantee that it will work well in the pre-production and the production, because as long as you have the underlying operating system there, it will operate in the same way. So there's no friction, no dependencies, no configuration dependencies that can that make the developers and IT operations struggle, and we will move away from the development team packaging application in a certain way and then throwing it to the operations teams to operate it, and this is where many problems happen traditionally. So we will eliminate all of these challenges, and we will able to achieve improved performance, as well as hybrid cloud and multi-cloud capabilities. Now, for the business, with such platforms, with container platforms, they will be able to basically think of an idea, come up with a new business idea, and quickly put that idea into code and move that code into deployment and move it into production quickly. So they will be able to achieve a DevOps culture, they will enable hybrid clouds, and definitely accelerate application delivery cycles. So it's good to everyone in the organization, for developers, for the business, and for IT operations. Now, I wanted to highlight that containers are Linux, right? And this brings a great advantage to Red Hat, because we are basically the worldwide leader in the enterprise Linux market. So this gives us great leverage in how we are able to drive container platforms and how we are able to manage container platforms and bring all the capabilities and the expertise and the security and technical supremacy of our products into the container platforms. So always remember that the applications that are running in containers are running in Linux, and that the containers themselves depend on Linux features, and that Linux is always foundational to containers. And Kubernetes, the technology that we're going to talk about later in the presentation, uses Linux to manage these resources, right? And definitely Red Hat is the leading Linux for the enterprise. And this brings a great leverage, a great power to Red Hat in how we manage, how we secure, how we orchestrate, and we bring enterprise capabilities to our customers on top of the Linux, of Red Hat Linux in the container platforms. And looking at Linux, Linux today is the most used platform for virtual machines in the public cloud. Almost 50% of Microsoft Azure VMs are Linux, and almost 54% of all applications running in public cloud infrastructures are running on Linux virtual machines. So Linux exists, predominantly in public clouds, and it is the leading operating system for developing the new cloud-native applications. So all the modern applications leverage Linux, and Linux is spread everywhere, right? And this also gives a great advantage to Red Hat being the worldwide leader in enterprise Linux, today. And we bring all of these features and expertise of Red Hat into our OpenShift container platform. Now, looking at the advantage of container platforms, because they rely on a Linux operating system underneath, right? And it enables these container platforms that are packaging these modern applications to become portable across different environments. As you can see here, the red layer represents the Linux, which can be spread between the laptop of the developer or bare metal hosting or virtualization platform or private cloud or any public cloud. As long as these platforms have consistent Linux on top of them, then the ability to move containers, workloads, and applications across these environments become a simple thing that everyone can achieve. So with containers, it's a guaranteed portability across any infrastructure. So this is where we can speed development of applications, and hybrid cloud becomes a reality. Now, if we want to compare this kind of architecture to the virtualization world, where we are able to package, in each and every virtual machine, the application with the operating system dependencies and an underlying operating system, complete operating system, and the friction that happens between these layers, and the friction that happens with the underlying infrastructure, and we want to achieve portability between these environments and hybrid cloud. This is not really easy to do. There's a lot of friction, lots of technical difficulties. That's why virtualization is considered as not the right technology to provide portability across environments or hybrid cloud, experience. And I'm sure you all heard about hybrid cloud, maybe at least 7 to 8 years, back. But actually, it didn't really happen with virtual machines. It's not easy. A virtual machine is tens of gigabytes. It is very heavy. It's a complete operating system, each and every virtual machine, with lots of frictions, with lots of dependencies. While with containers, we're only packaging the application itself. No operating system, lightweight, no dependencies. Okay, so hybrid cloud can be achieved with containers, while with virtual machines, it's almost impossible. Unless definitely there is specific criteria for the full architecture between your on-premise and that public cloud. But again, it's not the optimal platform for hybrid cloud. So hybrid cloud is designed for containers. Containers enable hybrid cloud and portability across different environments. Now, talking about containers and their advantages, we talked about that modern applications are now packaged, using container platforms. They enable, portability, easier lifecycle management, DevOps, and hybrid cloud deployments. But really, how can containers help customers who have old monolithic architectures, and how can Redhat really talk to our customers? So we look at the old IT stack and the old monolithic architecture of applications, where you have, a single application with multiple services, deployed on top of that application, a monolithic architecture of that application. And we look at how the modern technologies and how Redhat and how the container platform and how OpenShift can help our customers modernize these applications. So we look at this transition of the old application into maybe part of the application, as you can see here, can remain in the old architecture and can be deployed on, let's say, still virtual machines, right, as we modernize this application. But we can remove some services from that application, right, such as, for example, authentication services, such as, for example, payment gateway services, such as identity management services, such as, data services. We can remove some services out of that application and move them into microservices that we are able to package in containers, for example, and we are able to develop each and every service separately, using different language, using different teams, using different tools, right? And then part of these microservices can be deployed on-premise or across hybrid clouds, right? So we see this transition of a traditional monolithic application that we see on the left into a combined or a mixed architecture of, virtual machine hosted services traditionally and microservices, some services hosted through microservices on container platforms, and deployment across hybrid cloud maybe. So this is the new architecture of how customers will use and how they will modernize their applications. It's a modern, loosely connected microservices talking to each other through APIs, and allowing more services, including events, data-driven architectures, and enterprise integration patterns to be enabling this kind of architecture. So this is how the modernization of applications we see, and this requires container platforms. This requires a modern architecture based on containers, and we can look at our data center, today mainly dominated by virtualization technology, and virtualization technology is now a commodity and it's a legacy technology. And the new modern data center needs to be built on an architecture of containers, of loosely coupled services, of a platform that is powered by open source, and giving our customers all the modern packaging capability and portability of applications across hybrid clouds. And this is what Red Hat offers, the ability to build this new architecture, this new stack. So in this new stack, we all agree that modern workloads packaging and the data center architecture will be based on workloads hosted in containers, and these containers need to run on a platform, right? This platform should be unique, should be fully capable, should be enterprise grade, should be secure, to make sure that as we grow our container platforms, as we see here, right, as we end up with hundreds of containers and maybe thousands of containers, right, as we package more and more applications using containers, and as our off-the-shelf applications become containerized, we will end up with hundreds and thousands of containers. So the main question comes to mind: how are we able to manage these containers? How we are able to really provide enterprise scheduling, orchestration, availability, scalability, storage services, networking services, monitoring, and so on, capabilities to these containers? Because we are now moving from a data center that is orchestrated or architected based on virtualization technology, and we are now moving into a modern architecture, much more agile, much more capable, that is based on container architecture. So what kind of tools we need to have to help us manage this scale of containers? This is where technologies such as Kubernetes come to mind. So Kubernetes is an open source, basically, project with a new release every 3 months. And it helps to automate the deployment and the operation and the scaling of containerized applications across multiple hosts and definitely across multiple clusters. So it offers scheduling, auto-scaling, self-healing. It can support stateless and stateful applications and can support automated deployments. It can make the life of a developer much easier in how they develop applications, scale applications, and quickly deploy application across hosts. So Kubernetes is the technology that all the vendors, all the industry has converged on as the container orchestration engine of choice. So now we have a unique technology across all vendors and across all public clouds that they have standardized on to manage and orchestrate containers. And this is great, because with this, Kubernetes becomes the API of cloud. So when you hear your customers talk about, I want a hybrid cloud, I want to move into hybrid cloud, the first thing that comes to your mind then, okay, now we have a unique technology standardized across all vendors, across on-premise and off-premise and across public cloud providers, which is Kubernetes. And Kubernetes is the API of the cloud. So if the customer wants to enable hybrid cloud, right, Kubernetes is a must for that customer. So let's talk about how we can help the customer leverage Kubernetes and build a Kubernetes architecture or a container platform strategy. So this is where Red Hat comes to play, because Red Hat has been a big player within Kubernetes for over 5 years. Red Hat was the first, vendor, after Google, who basically, put Kubernetes as an open source project. Red Hat was the first vendor to make an enterprise version of Kubernetes with OpenShift 5 years ago. So Red Hat has a big head start over all other vendors in understanding Kubernetes, in building services around Kubernetes, and building much more enterprise capabilities around Kubernetes to make sure that when customers deploy it in an enterprise, they have the full enterprise requirements from security perspective, from visibility perspective, from management, from lifecycle actions, from upgrades, from patching, etc. So again, Red Hat has a big head start over all others on Kubernetes. And we have, again, of course, the largest customer base, and it is considered as the enterprise trusted Kubernetes, right? Because we've been there much before others. So based on this expertise of Red Hat, we have identified that, Kubernetes itself is a complex technology, right? It's not an easy technology in how you want to deploy it, how you want to manage it, how you want to harden it and secure it and operate it, on a day-to-day basis, how you need to patch it and fix all the bugs and make sure that, you have all the monitoring and all the storage services, networking services, logging services, and so on. So there's a lot of, operational requirements when customers want to deploy Kubernetes. And take into consideration that Kubernetes as a technology is not enough. It's like you are buying a car, but you are only actually buying the engine and the gear of the car. You cannot really drive a car with only engine and gear. You need seats, you need dashboards, you need windows, you need airbags, you need audio, you need software, you need a lot of things to really give you the enterprise look and feel of an enterprise platform. So Kubernetes itself is not enough. So when you hear about Kubernetes, definitely it's the core technology behind container orchestration tools, but itself is not enough. A vendor needs to provide much more capabilities and tools around Kubernetes to complement it, to give you this enterprise look and feel. And this is where Red Hat, with our Kubernetes expertise, with our Kubernetes leadership, with our Linux, which are the base of containers, comes to play. And we are offering on top of Kubernetes all of these capabilities that you see on the slide, to complement it, to give you this enterprise experience, to make sure that when you deploy OpenShift, on-premise or on a hybrid cloud, and when you use Red Hat OpenShift, you get the full enterprise experience, the mature experience, the enterprise grade with the full security, with the full monitoring capabilities, with the full lifecycle actions, the upgrades of all of the components. So what Kubernetes needs more, and this is required by developers and operations teams, is tools such as CI/CD pipelines, right? You need a collaboration platform for the development team and the operations team. We provide multi-tenancy capability on top of that. We provide role-based access control, integration with your Active Directory or authentication system. We have capacity management, showback, chargeback, vulnerability scanning, isolation between the containers and security. We provide certifications. We provide, quota management and infrastructure visibility, and much more than this. So all of these tools, and also networking services and storage services, all of these tools complement Kubernetes to give you the enterprise look and feel. And this is what OpenShift provides. It provides you Kubernetes plus all of these combined in a single package, in addition to Linux, with a single product, with a single subscription, with a single lifecycle action, right? This is what Red Hat offers with OpenShift. So OpenShift is the trusted enterprise Kubernetes. It's not only Kubernetes. Kubernetes itself is not enough for enterprises. They need much more. And as you can see on the left hand side of the cloud of the slide, you have the Kubernetes, and you have over 10 other projects that give the Kubernetes, the enterprise look and feel and experience that enterprises expect. Now imagine that each of these projects have its own life cycle, and Kubernetes itself has its life cycle. And the Linux operating system itself has its own life cycle. So when you want to come up with a product, with a single product that combines all of these, managing the life cycle of all of these, fixing the bugs across all of these, certifying the integration, certifying how all of these, projects, use and leverage each other, it's not an easy job. So Red Hat with OpenShift as the trusted enterprise Kubernetes removes all of this complexity from the customer and brings you one enterprise product that leverages all of these technologies that you see on the left and the Linux operating system, and gives you the industry most secure, enterprise-grade container platform that has existed, for over 5 years, with over 2,000 customers today, with hundreds of defect and performance fixes in each release, with a 9 years enterprise lifecycle management, with certified container ecosystem, and with over 200 validated integrations. And this is the experience that we give our customers, the trust of a working platform, tested, certified, and with a lot of certifications and proofs, industry proofs around it. So OpenShift is our Red Hat container and DevOps platform. It doesn't only allow containerized applications to be hosted, but it also provides developers with all the tools, with all the capabilities with all the productivity needs, such as languages, frameworks, databases, integration capabilities, API management capabilities, to become productive and to basically move code from development into production in minutes. So we really provide not only the platform, but also the tools for the developers to become productive. And it doesn't only support traditional applications, which can be containerized or can run still on virtual machines, but it also supports the development of modern cloud-native applications and modern AI and machine learning functions, right? So you have technologies such as Cloudera, now certified to run on OpenShift. We have even core banking solutions certified to run on Redhat OpenShift, right? So we're not talking about rocket science technology. We're talking about the technology that's supporting mainstream enterprise-grade applications, which has proven that running on OpenShift provides advantages in terms of performance, in terms of scalability, and in terms of packaging and lifecycle actions, right? And one of the main advantages of Redhat OpenShift container platform is that it can be deployed everywhere, on your laptop, on a physical server, on a virtualized server from VMware or from others, or from Red Hat virtualization or on OpenStack, or it can be deployed on any public cloud. All of the big public cloud providers support OpenShift. So your hybrid cloud becomes a reality. With Red Hat OpenShift version 4, the latest releases of OpenShift, we came up with a lot of new innovations. And mostly it's around simplifying day one and day two operations of OpenShift. So now with Red Hat OpenShift, it's a fully automated installation of the operating system, of the Kubernetes platform, and of all the developer tools that Red Hat puts on top, and with all the networking services, storage services, logging, monitoring, and dashboards. They all come with a single installation. It's a fully automated installation. Not only this, but we also offer what we call the over-the-air updates. So the life cycle of that platform happens over the air in a fully automated way. When you want to patch, when you want to upgrade that platform, it automatically shuts down specific clusters and pods and move them into another clusters to make sure that the high availability of the platform is consistent while it's updating itself. So we provided a lot of innovation in how the platform updates itself over the air, simultaneously, like you update your mobile device in a way, so automated updates. And not only this, but we also introduced the concept of operators. So what are operators? It's basically taking the, like a real life operator and how he updates the platform. We took that technical knowledge of operators and we codified that into the platform. So the platform updates itself by itself, and all the services that are running on top of it, whether they are the monitoring services, the storage services, the logging services, even the Red Hat middleware services, all of these have their own operators that also update these services as the platform is updating itself. So we have the cloud, experience now with OpenShift, also a Red Hat innovation, where you have really a real cloud-like experience in operating the platform and updating the platform and all the services, and even a lot of the applications that can run on the platform with the concept of operators, and these applications having their own operators as well can update themselves as the platform is updating itself. Again, look at it, compare it to a mobile application. As you update your mobile, all your applications are also updated as well. And this is the same, right? As you are updating OpenShift with the concept of operators, all the services, all the applications that have operators on top of OpenShift gets updated as well. So imagine the simplification of day one and day two operations that our customers can achieve. It's the most innovative container platform in the industry, secure by default. It runs on the world-leading secure Linux with fully multi-tenant capabilities, monitoring, chargeback, and it's a pluggable architecture that allows the customer to deploy it on any infrastructure, whether it's bare metal, VMware vSphere, Red Hat virtualization, OpenStack, AWS, Microsoft Azure, Google, and IBM Cloud. It runs consistently on all of these platforms. So no lock-in technology based on the open source, Red Hat development model. Again, in terms of security, we've talked about OpenShift as the architecture of the modern data center. So we need to make sure that this platform is secure, is certified. It's make sure that it gets all the enterprise certifications that enterprise customers and enterprise regulations require. So Red Hat has a comprehensive container security that is unmatched by any other platform, right? So if you're talking about PSS, PCI compliance, HIPAA compliance, and other requirements, Red Hat is ready. Red Hat OpenShift platform is ready with all of these platforms, and the ecosystem and the architecture based on Red Hat Linux security capabilities makes sure that these are translated throughout the architecture of the OpenShift. Not only this, but very important that OpenShift is not only a container platform, but it also gives developers all the tools, all the ecosystem of services that they need to become productive quickly, right? So what we offer them is a fully automated way to write code, build it, test it, and deploy it in a fully automated way. So we provide automated pipelines, we have automated build and deploy capabilities, we have self-service capabilities, so the developer can choose the languages they want, the frameworks they want, the databases they want. It has built-in Jenkins and supported Jenkins as well. It has also application logs and metrics. They can define the scalability requirements of their application. They can do automated rollout of applications and much more, right? So it enables the developers to quickly develop microservices. It gives them Spring, frameworks, Java frameworks, a host of languages and databases at their fingertips. And again, it supports Linux containers and soon to come Windows containers as well. So again, it's the most mature platform that gives the developers all of the tools, all of the capabilities at their fingertips to become much more productive and develop services and code and software quickly and move it from development to production in minutes. So I don't want to talk extensively about the development tools, but again, these are unmatched by any container platform in the industry, right? And remember that Red Hat complements the Red Hat OpenShift with Red Hat middleware. So customers can get API management capabilities, automated processes. They can get integration out of the box with that, messaging, and API management, as I mentioned earlier. So we offer developer consoles with dashboards for onboarding, application and visibility, information about the components and visibility on how the whole application architecture is being deployed. We provide Helm packaging to help install, update, and share Kubernetes applications. It has developer CLIs, and it integrates with IDE environments with Visual Studio Code, and it has ready plugins as well. And we also introduced lately code-ready containers and code-ready workspaces, which is basically code-ready containers is a local OpenShift cluster on the developer workstation. So the developer can get productive anywhere he goes. And we have also have code-ready workspaces, which is a collaborative Kubernetes native web-based IDE, okay, where they can collaborate and on a hosted Kubernetes across different teams for collaboration. So again, all of these tools combined give the developers an unmatched experience to have all what they want at their fingertips in a self-service, look and feel. Also, one of the special differentiators of OpenShift is its ability to be deployed across hybrid clouds. So as you can see here, Red Hat OpenShift is available on AWS. It's either a Red Hat OpenShift dedicated managed by Red Hat, or it can be also customer managed. So this is one option. Another option is Red Hat on Microsoft Azure. It can also be offered as a combined managed platform by Microsoft and Red Hat with Red Hat Azure Red Hat OpenShift, or the customer can deploy OpenShift and be self-managed. We also offer it on Google as well as a managed service, or the customer can have it as self-managed. Also, it's available on IBM Cloud, or it can be deployed on any on-premise platform customer managed as well. So no other container platform gives this kind of visibility and this kind of hybrid cloud interoperability and choice to your customers. So when your customers ask about, they want to move to the public cloud, always remember that the end goal of the customer is not only to move to that public cloud provider, but what the main question is, what if his business requirements change and he wants to move out to another public cloud provider? What is his insurance policy? How can he do that, right? And this is where OpenShift comes to play as the true container platform for the hybrid cloud that offers choice and portability across different environments. So if the customer is running applications on OpenShift on-premise, he can choose at any time to deploy them on any public cloud, or to move from any public cloud to another public cloud based on their business requirements, based on their commercial advantages, or based on any kind of operational requirements that they need. So OpenShift gives them choice and consistency and no lock-in across any private and public cloud and infrastructure platform. And if we want to look in more details into the Red Hat architecture, OpenShift architecture, again, if we start from the bottom, we have the first 3 layers that offers you the basic OpenShift container platform, something we call the OpenShift Kubernetes engine. So this is only a container as a service platform, right? And it's a combination of the Red Hat Linux with the Kubernetes, with the cluster services that offers automated installation, automated operation with over-the-air updates, monitoring, registry, networking services, and router services, and so on. So this is for customers who want only a container platform with no developer tools, right? So we offer what we call the OpenShift container engine, the one that you see on the left. Now, if the customer definitely needs to make his development teams productive, he needs to give them all the tools, on all the languages, all the frameworks to develop applications quickly on their, at the tip of their fingertips whenever they want in a self-service way. So this is where the layer that you see in light blue comes to play. So we offer platform services such as service mesh, serverless, CI/CD pipelines, chargeback and logging for those developers. We also offer databases, languages, runtimes, integration capabilities, and business automation, and over 100 ISV services that are available and certified on top of Red Hat OpenShift. And also, the customers want to become more productive, of the developers' tools to become more productive, we offer, the IDE integrations, Visual Studio Code extensions, CLI, workspaces, code-ready workspaces, and code-ready containers, which is a complete OpenShift on their laptop to start deploy, and code whatever they want as well. So for developers, the ability to build cloud-native applications, manage workloads, and to become more productive is at the heart of the OpenShift container platform, and it gives them true platform as a service capabilities. Now, one of the interesting, additions to Red Hat OpenShift that we have introduced lately is the multi-cluster management, right? Through a product called Advanced Cluster Management, or ACM. So this allows the customers, as their business requirements needs for them to deploy clusters on-premise or across one public cloud or across multiple public clouds. ACM allows them to provision Kubernetes clusters across multiple deployments, across on-premise and across multiple public clouds, and manage them through a single pane of glass. So this brings hybrid cloud management and operations into reality, right? And this is part of this section, which is what's new with Red Hat OpenShift, the latest releases. So what we are bringing new with Red Hat OpenShift is basically we understand that modern applications, right, can be packaged in containers, but some developers still need to package, some applications in virtual machines, because these applications will not benefit from the application services. From the container, platform. They will still need to be deployed in virtual machines. So we're bringing what we call the Red Hat OpenShift and OpenShift virtualization as part of the OpenShift. So now Red Hat OpenShift offers not only containers, but also virtual machines. And virtual machines can sit side by side with containers and can be managed by the same tools. They leverage the same networking services, the same storage services, and can be orchestrated in the same way like a container. So now Red Hat OpenShift brings not only containers, but also virtual machines into the platform. And this also is a very strategic step as we want to modernize the architecture of our data center on a unique Kubernetes-based infrastructure, and this same Kubernetes-based infrastructure platform can provide us containers and virtual machines, and also a new architecture of deploying applications, which is called serverless, right? So serverless allows the applications to scale to zero and allows these applications to be provisioned instantaneously based on a specific trigger or a specific data stream. So something we will hear more and more in the future. So just to summarize that, OpenShift today has become a platform for the modern architecture, for the architecture of the modern data center, and it enables the deployment not only of containers, but also of virtual machines and of serverless, ready for the new cloud-native applications and ready for the modern data center from day one, and with full hybrid cloud interoperability across any public cloud providers. So now you are able to modernize legacy virtual machine applications and deploy them over the container platform, and you are able to standardize on one platform to manage virtual machines and containers, right? So now you have a unified management of virtual machines and containers. And this is something that, is a great advantage as we want to simplify the architecture of our data center. We don't want to build the data center, the modern architecture of the data center on top of old virtualization technology. That's not the Red Hat way. We want basically to make sure that we are building a complete new architecture based on Kubernetes, and that modern architecture of Kubernetes provide us, with both containers and virtual machines. This is how we see it as Red Hat as the best architecture of the modern data center. Simple, unified, and brings the best value of both worlds, containers and virtual machines. Now, also talking about hybrid and multi-cloud, customers have always struggled with multi-cloud management, okay? Because, as customers want to leverage multiple clouds, it's really hard and error-prone to manage at scale and to have common visibility and common API calls to multiple public clouds. And really, it's sometimes very hard and overwhelming to be able to verify components, configuration, policies, and compliance across hybrid clouds. That's why, as customers, as many of the modern enterprises are going into hybrid cloud deployment models, and they have a need to manage deployment of applications across these hybrid clouds. This is where the Red Hat multi-cloud management with the Red Hat ACM comes to play. And it's basically, with Kubernetes, customers will need to deploy multiple clusters across different deployments. So they might have one cluster for the development of their applications on one public cloud, and another team is testing another application on another public cloud, but their actual production environment is hosted on-premise on physical servers, and they also have a DR that is hosted on-premise. So how are they able to have a unified view of these multiple clusters across hybrid clouds in a unified way to simplify the management, the visibility, and the policy enforcement of all of the deployments across these hybrid clouds? This is where Red Hat ACM, Hybrid Cloud Multi-Cluster Management, comes to play, where we are offering our customers a unique tool, a unified tool for them to provision Kubernetes clusters on-premise and across any public cloud with a single visibility, with a single governance to show them, not only what's happening in each and every cluster, but also to monitor the capacity of each and every cluster deployment, monitor issues, troubleshoot issues, and take corrective actions, and also the ability to know what is the utilization on each cluster, what's the performance of applications on each cluster, and to manage their subscription issues and visibility across the hybrid cloud deployment. So again, it's a holistic view of how the customers need to manage multi-cluster deployments across hybrid clouds, and we already are offering that today with Red Hat, ACM for hybrid cloud management. Again, another view of how we are able to unify the multi-cluster management across multiple clouds as well. So when the customers ask you that we have a hybrid cloud strategy, help us build a hybrid cloud strategy, this is where Red Hat really have the expertise, we have the technology, and we have the consultancy to look at the customer existing applications, do complete assessment of these applications and come up with a strategy to the customer of which applications are better suited to remain on-premise and which applications really can be containerized. And once containerized, we can deploy them on hybrid clouds. And once we deploy them on hybrid clouds, how we are able to manage them using a single unified tools across these hybrid clouds while maintaining security, compliance, and governance of our applications across these deployments. So this is something that Red Hat is offering. And again, we are leaders in the market in this platform. So to summarize, with OpenShift, it is not only a container platform, but we are able to offer our customers mixed applications of virtual machines, containers, and serverless today on a single platform that can be deployed across physical, virtual, and across multiple public clouds. And you are able to shift your workloads as your business requirement, as your business requires across these public clouds based on the commercial needs, based on operational needs, based on business needs, as your business requires change over time. And again, with Red Hat OpenShift, it's the worldwide leading platform for containers and also for virtual machines now and serverless, and it can be deployed on physical, virtual, and any public cloud. So finally, why OpenShift? Many customers ask us. It's because again, we have been the first vendor to leverage Kubernetes and bring it as an enterprise product to the market. We have extensive experience. We have thousands of customers, and again, as this slide shows, we have leading market share, and now our market share is even higher than this. So we understand containers, we understand applications, we understand application modernization requirements and microservices architecture and how containers play into that. Red Hat has the leading Linux market share. We have the leading basically architecture of container platforms. And again, we have extensive experience and consultancy around helping customers modernize their applications and move into a hybrid cloud deployment model. And on top of this, and the latest Forrester, basically analyst paper on basically multi-cloud container development platform, which was announced last month, Red Hat, is among the top leaders. Red Hat IBM platform is basically taking the leading role in multi-cloud container development platform, and this is for many reasons that are listed here, right? And as per the customers and as per the analyst feedback, Red Hat is ideal for both cloud-native organizations and large enterprises with customer legacy applications. So we cater for the needs of customers who have legacy applications, so we understand old application architectures, and we are able to modernize these architectures into modern cloud-native requirements. So we cater for both needs. Again, another quote is the development experience, the distributed operations and ecosystem integrations are key differentiators. Again, based on open source, our ability to integrate with multiple technology, no customer lock-in, no prerequisites on the infrastructure, the ecosystem of ISVs that are certified on our OpenShift platform is unmatched. And with our ACM, Advanced Cluster Management, we are able to take deployment of clusters across any public cloud, across any Kubernetes deployment into new levels. Another quote is, OpenShift is the most widely deployed multi-cloud container platform. I mentioned that earlier. Red Hat pioneered the operator model for infrastructure and application management. Again, the concept of operators, the ability of the platform to update itself by itself, and all the services and all the applications that are running on OpenShift have operators that also update themselves as the platform is updating itself, is also a unique a feature that Red Hat has pioneered and introduced. And also this is, an innovation that is basically adding to our reputation. Finally, reference customers gave OpenShift high marks for first-class customer service and support. Again, you remember when I mentioned that, Kubernetes is a complex technology. What if we add to it more than 10 other projects and also the Linux, and managing the whole life cycle of these projects and making sure that we are giving our customers an enterprise product that is, unified with unified installation, unified lifecycle management, fully automated operations. Not only this, but also with, the best in class service and support around it, right? So this is what Red Hat offers our customers. We are not in version 1, we're not in beta. we are a platform that is in our almost 17th or 18th release right now. It's a trusted, proven enterprise Kubernetes platform. Finally, the last comment, Red Hat aims to make build once, deploy anywhere a reality. And I think this quote says it all. It's basically a simplified experience of building your application once and deploy it on any platform where Red Hat OpenShift, is available, which is basically on all infrastructure providers. So moving OpenShift further ahead of the market since Forrester's last evaluation. So we are bringing more and more innovations, and you're going to see, Red Hat position, remaining in the leading quadrant of multi-cloud container development platforms and other research as well. In terms of our in terms of the Red Hat presence, definitely we exist, and we are growing, quarter over quarter with enterprise customers who have transformed into Red Hat OpenShift as their enterprise application platform. And again, this slide I think says part of the story, but we have local, wins, we have regional wins, as well as we have worldwide wins. We have the biggest names in the market across all sectors, across all verticals, across all industries. So it's a proven platform. And again, Red Hat understands applications, understand developer needs, no lock-in technology based on leading Kubernetes, simplified architecture offering containers, virtual machines, and serverless, and building the architecture of the modern data center. We have a very good, a success story with Emirates MBD, who won the Red Hat Innovation Awards last year. So again, Emirates MBD standardized their cloud, their development cloud on Red Hat OpenShift, and since then, basically, they helped to transform their application architectures into container platforms, leveraging multiple technologies from Red Hat as well, and they were able to develop, and speed up their mobile banking and lately their social banking also based on Red Hat OpenShift, to become the leading innovative banking platform in the region as well. And also, I'm sure you know about the WhatsApp banking from Emirates MBD, which was developed also based on Red Hat OpenShift. So this goes back to the idea economy, where an enterprise has an innovative idea, such as here, for example, WhatsApp banking, and with OpenShift platform, we can make that idea come to production quickly. We can make the ideas happen, and we can make that business very competitive, and we can make that business, we can help businesses become differentiated and add value to their, day-to-day business, and making sure that their customers are happy, satisfied, and their market share is increasing. So this is a real-life example of how OpenShift can help customers become more innovative and helping bring new ideas to the market faster. Why Red Hat is the best choice? Again, I just want to highlight that in terms of code, right, we are the second largest contributor to Kubernetes. We are driving the architecture of Kubernetes, which is the API of the modern cloud. We have the best experience with Kubernetes, and our engineers and all our Red Hat technologists are working on developing features and capabilities, and we are bringing new also features into Kubernetes day after day and release after release. In terms of our customer base, we have the largest customer base with over 2,000 enterprise customers across all verticals, across all sectors in the market, in the region, across airlines, across banking, across government, across financial institutions. We have references in each and every country. We are available across all public clouds in both, self-managed and in fully managed modes. Okay, again, nobody really matches that kind of capability. And finally, in terms of the architecture of Red Hat OpenShift, nobody really matches OpenShift ecosystem of, developer tools, developer toolkits, languages, frameworks, middleware architectures, middleware capabilities, as well as the advanced cluster management to manage Kubernetes platforms across hybrid clouds, and the multiple services that we are complementing Kubernetes with is completely unmatched. So you get the full enterprise experience with Red Hat, trusted and certified. So with that, I want to end with the final slide, which is the Red Hat services for OpenShift adoption, and we want to make sure that when we sell a technology, okay, it's not only about the technology. We understand that organizations to become, very productive and very innovative, they need to, they need the support of a partner, okay, who can work with them hand in hand to show them how, we are able to move from the old legacy architecture to the modern architecture, how we are able to change the traditional processes that exist today and help them modernize them and automate them using the new OpenShift and the Devops culture. So we have what we call the Red Hat Open Innovation Lab, which is basically the ability of, of Red Hat to come to our customers and show them hand in hand, teams working together and collaborating together on moving from the old way of doing things to the new way of doing things. So we work side by side with experts in a residency style engagement, and we help achieve results together, right? Even if that requirement was an idea, we can help show the customers that idea, we can bring it into a minimum viable product or MVP, together, working together in an easy way. So we can bring ideas into reality together. On the right-hand side, we also have the Red Hat Container Adoption Program. So if the customer, wants, some consultancy around really how he is able to, move their applications into container platforms, and then from that into a hybrid cloud, how they can build a hybrid cloud strategy. Red Hat has all the tools, all the consultancy and expertise to do full assessment of the customer existing environment, all their application stacks, and come up with an approach to modernizing their applications on a phase-by-phase basis to move them into their, holistic approach to hybrid cloud in a phased approach. So it's a step-by-step, approach to understanding customer requirements, understanding the business needs, looking at their technical details and technical architectures, and driving a plan and a phased approach to container adoption. So we have all of these services for our customers and for our partners to leverage and to build a hybrid cloud strategy and the container adoption framework for our customers. And with that, I would like to advise you to log into learn.openshift.com, and you will see a lot of tools around OpenShift, foundations of OpenShift, even a self-paced, a quick OpenShift deployment with a quick, scenarios on how you can start to use OpenShift. So it's a very nice learning for partners and customers to start to know OpenShift in a bit more depth and try to test OpenShift and know more about OpenShift in predefined scenarios and use cases. So again, lots of information that you can get from learn.openshift.com with an interactive learning scenarios with a pre-configured OpenShift instance accessible from your browser without any downloads or configuration. You are welcome to use it and to advise your customers also to use it. And, seeing is believing, as they say. So with that, I'm done. Thank you all. And, if you have any questions, I'll be happy to answer in the remaining, I think we have almost 10 minutes. If anybody has any question, I'll be happy to answer.
In detail, please feel free to reach out to me. We are looking forward to our next presentation from Balbaki on Ansible, which will help you to understand how to automate your current infrastructure and applications. Thank you so much again. Have a good time. Stay safe. Bye-bye.
Bye-bye. Thank you.